Good afternoon, everybody. I just want to say thank you for coming to my vBrownbag session today in the hang space. This is a few gotchas with SQL Server virtualization. My name is David Klee. I'm lucky enough to be a Microsoft MVP and a VMware vExpert, and I actually started a company 2 years ago to focus on the convergence of infrastructure and data. I have a very, very heavy emphasis on SQL Server virtualization, performance tuning, and availability. So how many of you have virtualized all of your SQL servers, and you wonder why the resources are just so crazy consumed? SQL Server is one of the biggest resource hogs in your environment. Well, why? There's a lot of things you have to worry about when it comes to SQL Server virtualization. A lot of these things you don't have to worry about with regular VMs, but SQL Server, it consumes so much resources. And why? The biggest thing to worry about, a lot of these gotchas, storage, performance. So one big thing about a database server is that memory acts as an I/O buffer. So if you give it more RAM, generally speaking, you're going to get better I/O performance. If you've got something that is just absolutely burying a SAN, think about giving it more RAM. Now, one of the other things is you have to have fast interconnects. Not only do you have to have a fast storage device, but you got to be able to get there and back very, very quickly. So the fastest possible interconnects and the most you can possibly get. And then set up multipathing properly. So round-robin IOPS equals 1, round-robin multipathing scenario, any third-party multipathing venue or module out there, set it up, because if you're only using one out of any number that you have, it'll make a big difference. The disk configuration on the SAN itself and in the VM also matters. With the SAN, you want the fastest possible write and random activity performance. So a lot of times RAID 5 or RAID 6 just won't work nearly as well as others. You got to watch the space, but you got to make it work. The big thing here, SSD caching or tier that helps. Latency on SQL Server will bury you. I've even started using some host-level I/O acceleration, so namely Pernix Data Fast VP. I normally don't name products in presentations like this, but it really does work well. Most OLTP databases are 80% read, 20% write. If you buffer half of the reads, it's huge. It makes a tremendous performance improvement on a database server. One of the other things there is sometimes you can even have I/O queue problems inside Windows, even before it gets out of the VM. So spread out the workload. And what do I mean by this? Well, from a VM admin perspective, a lot of folks don't have hands-on experience with SQL Server. So this is what's actually going on under the covers there. You've got I/O handling through memory. You've got different databases, different instances. Each database has different file groups and files in there. This gives the DBA the ability to spread out the workload between logical drives and therefore multiple virtual disks. If you set up multiple SCSI controllers, you can start to add I/O queues inside Windows, and you can cut down some of these bottlenecks. It really does matter for the larger workloads. For the smaller ones, probably won't make that big of a difference, but you can help future-proof your environment. Now, so you've got a fast SAN. What do you know that, how does it actually perform when it comes to the database and the Windows OS inside the VM? What are the maximums there? So the things that we care about when we go do these tests: latency and IOPS. Throughput is a distant third. Just so you know, there's some tools out there. SQL I/O is recently deprecated by Microsoft. It says SQL in the name. It's actually just a command line disk utility that I love, until they replaced it with disk speed. I love it. Now, I've got a PowerShell wrapper out there at hairflux.com/go/disk speed that will help you test and automate the testing of a storage device. It ramps up the different iterations, so read and write, random and sequential. It ramps up the intensity on the test, and it's awesome. It gives you sub-millisecond granularity. It gives you a histogram to tell you what the storage is actually doing under the different degrees of load. Graph the results by the averages of the operations per thread, because a picture says 1,000 words. Even a C-level people can see that you have a problem with this SAN. What was going on? We had cache controller issues with a buffer cache in there. We added some more, problem went away. Now at the host level itself, what happens? A lot of times there's an interesting discussion between DBAs and VM admins. If I'm a VM admin, I need to go buy a host. What do? I need more cores, not necessarily faster cores. However, at the database layer, one, you got to pay by licensing of those cores. So if you're not getting the biggest bang for the buck for the core itself, you might be doing the database a disservice. So I always say, one, ideally, I want faster cores and the most possible cores. But if you can't get that, I say go faster cores over more cores. Because if you look, the E5 V3 CPUs, the difference between a 2 gig CPU core and a 2.8, 2.7, it's upwards of about a 30-35% performance improvement. That's substantial. That can be an impactful operation per query. It really does matter. Now, biggest thing to remember, 0 memory over commitment at all. No memory over commitment. I cannot stress this enough. This is performance-oriented engineering. You're designing for performance first, consolidation second. Get the maximum memory density in the host that you can afford, because realistically, if you track the CPU ready time, if you track co-stop, you're going to run out of RAM well before you run out of CPU power, so maximize the memory density. Again, more RAM means less I/O usually. Problem here is less host RAM, less RAM per VM means greater VM density, potentially less SQL Server licensing, and that is a huge cost, so you have to weigh that balance in there. What's good enough? The other thing is make sure the memory is in the fastest possible configuration. So did you know that if you fill up the last bank of RAM on some of these machines, it might actually speed down the RAM by up to 33%. On a database server that's so memory dependent, that could be a tremendous performance hit just by going cheap on RAM. So hit the memory configuration guide for your machine. You'll find the memory speed per RAM configuration. Easy. Full memory reservations for production as well. Just a little checkbox, reserve all guest memory. It's really easy. One, it gets rid of those huge swap files on the SAN, so you get some SAN space back. The other thing, there's absolutely no chance that you'll be ballooning inside the guest, and therefore your SQL servers are going to be fine. If you got other machines that can handle it, no big deal. Big, big, big tip. Active memory counters lie. I loaded 20 gigs of data into a database. After I loaded it, you can see from the chart here, I was still using it. Active memory counter went way down. It's really interesting. There's actually a document out on my blog from VMware Corporate that says this memory counter should be avoided for big database servers. It's really interesting because this measures the amount of memory touched in a 20-second window, not necessarily anything that's in use. Keep that in mind. This does not mean you can take memory away from that VM. So, one of the big things when it comes to CPU sizing, VM construction, things like that, the DBA is always going to ask for all the resources they can possibly get. It's a challenge because you know as well as I do, you give a VM more CPU resources than it needs, it's going to slow it down. So you have to show them, not just tell them to actually go in and drop some of that, some of the CPU. You have to show them that it does make a difference. Now, how to add a CPU also disables vNUMA, so think about that. SQL Server is extremely NUMA aware, so you can get a big 15, 20, 25% performance bump just by keeping that disabled. You got to work with the DBAs on the proper resources, the proper number of CPUs, and you can always go in and change this stuff. You can always go add more when you need it down the road. Proper sizing matters. Flat out ignore any crazy third-party vendor that demands, just ridiculous amounts of CPUs. Just ignore it. Just show them that it works without it. Numbers matter. Performance numbers matter. Put it in numbers, and you can get this thing passed anywhere. The biggest thing here, by doing that, the VM's got to be right-sized. So what do I mean by this? So let's say you've gone through and you've looked at all the performance numbers, and you can tell that you need 16 CPUs to run that database. Okay, well, what's the best configuration? 16 sockets, each with 1 core, 8 sockets, each with 2 cores, all the way down. Well, what do you think? Do you think it matters? Yeah, it definitely matters. And the cool thing is, it takes longer to graph it than it does to test it. Boom, check it out. This is a Hammer DB test. And you can see right here that under different degrees of intensity, this system responds differently. That is a 31% performance improvement in the end runtime of that database server just by changing the vCPU configuration. That's substantial. It does matter. Biggest thing here is education. A lot of DBAs just don't have the hands-on experience with virtualization, so they fear it. It's a black box to them. So you have to work with them. They have to know what's going on. They need access into vCenter so they can see what's going on, but you have to educate them so they know what they're looking at. Help them through it, and I promise you, your experience working with DBAs to virtualize all these things will be so much better. Make it transparent, give them access to the stats, and it will get better. Any questions? Cool. Well, thanks a lot.